So like I said, the next few lessons are very, very important because they're review lessons. So even if you were absent, had internet issues, or just didn't learn it altogether when we went through this lesson, you're going to get to learn it again right now. So very important to review. Number one, to refresh what you already learned and to learn things that you might have missed. So the first page is of solving literal equations. We call literal equations equations with more than one variable in it. So x, d, and f, x, z, j, all these have multiple variables in them. So these are actually easier than solving regular equations because a lot of the steps you don't have to solve for, you just write them out. So also here we have an equal sign, and on the right side we have inequality signs. I put them both on the same page because you solve them both the same way. The steps to solving them are the same. Equations and inequalities are still the same process in terms of solving them. So on number one over here, it says we're solving for x. So the first thing you do is avoid x and get rid of the other term that's on the same side as x. So if we avoid x, that shows us we need to get rid of plus d. Opposite of plus d is minus d. Whatever you do to one side, you do to the other. Now, this is why I say it's easy. Can you actually do f minus d in a calculator? Of course not. So you just write it out. The right side is going to say f minus d equals, and on the left side, what do we have left? Only 2x because the d got eliminated. Now, x is not by itself yet. One more step. 2x means 2 times x. What's the opposite of times? Division. So you need to divide by 2 on both sides because the goal is to leave the variable by itself. So now we have the variable by itself. We got x equals f minus d divided by 2. Now that is your answer because you can't divide letters by 2. So you just leave it like that and circle it. Now I'm gonna skip number 2 because that's one you're gonna do on your own. I'm gonna go straight to number 3, which is the inequality version of this question. Same process. We're solving for x, so we avoid x first, and we have to get rid of the term that's on the same side as x. How do you get rid of a minus z? By doing the opposite of minus z, which is plus z. Whatever you do to one side, you do to the other. Now, on the left side, we have 3x equals, and on the right side, we have 2j plus z. You can actually add j to 2 z to 2j. So we write it out, 2j plus z. Now last step is always division. You're dividing by 3 by the coefficient on both sides. And that's it. Now you have the answer. X equals 2j plus z divided by 3. So use the example that I showed you on number 1 and number 3 to complete number 2 and number 4 on your own. I'll give you 4 minutes. Go ahead and begin. Let's review those two questions. So on number 2, again, we're solving for x. So the first variable or term that we have to move or get out of there is the c because it's on the same side as the x. And the goal is to get the x by itself. So we need to start taking stuff away from that side. So we minus c on both sides first. That leaves us with 10x equals 20g minus c. You write it because you can't actually subtract two variables that are not the same variable. And now we divide both sides by the coefficient, which is 10. Now, if this was a multiple choice question, you would automatically look for this answer choice. Now, what if you get to the answer choices and none of them are 20g minus c over 10? That tells you I'm missing one step. So this is something I taught you guys in the past. If two terms are being divided by 1 on the bottom, then you can separate it into two different divisions. So 20g divided by 10 minus c divided by 10. Now, c divided by 10 you can't do. It stays like that. But 20 divided by 10 is 2. So that leaves us with our real answer, 2g minus c over 10. because this turns into 2g. 20g divided by 10 is 2g. Now, 9 times out of 10, you're going to find this answer choice on A through D, so you don't have to do this step. But this is me showing you, if you don't see the answer choice, this is the simple step you're missing. Any questions so far? All right, let's now review the purple question over here, number 4, which is the inequality. So again, we're solving for x. So we get rid of the other term that's on the same side as this x. We need to get rid of that h value. So because it says minus h, we do the opposite, plus h. Whatever you do to one side, you do to the other. So now we have 2x equal, well, 2x is less than 100f plus h. So far, so good. Now, the x is not by itself yet because there's a coefficient on it. The last step is always dividing by the coefficient. So we divide by 2 on both sides. Now, because we know that we have to simplify, let's already put it under both numbers. So divided by 2, divided by 2. That saves you a step. Now I can write my final answer already. X is less than 100f divided by 2 is 50f. And h divided by 2 comes down because it can't be done. Now, always remember, if you ever divide both sides by a negative, then you flip this inequality symbol. Because we did not divide by a negative, we're not flipping the inequality symbol. Copy down the work. Ask me any questions if you have them. Let's move on to the next page. Now, on the next page, these are two equations that have fractions in them. So, you can work with the fractions if you like. I don't recommend it. I recommend you get rid of fractions. So, let me explain to you the process here, and then you can choose which way you want to do it. So, on number 1 over here, I'm going to rewrite it so you can see it in fraction form here. 1/2 x plus parentheses 3x plus 2 plus x equals 200. Now, this is important. When you're getting rid of fractions, which is what I'm going to do on this problem, you have to multiply the entire equation, the whole thing, which means everything you see in there, by the denominator. So, because the denominator is 2, I know I'm going to multiply by 2. But before you do it, this is an important thing you have to remember. Anything in a parentheses does not get multiplied by 2. Only the number touching the parentheses gets multiplied by 2. So that tells you that, yeah, they're going to eventually get multiplied by 2, but after you distribute. That's important because if this number was not an imaginary 1 there, it was a 5, that changes your answer completely because you have to multiply the 5 by 2. So when I say multiply everything by the denominator, I mean everything except parentheses. So now let's do that. 2 times 1/2 x is 1x. 2 times 1 is positive 2. Remember, parentheses just comes down. 2 times x, positive 2x. And now the last term at the end over there, 2 times 200 is 400. Now, after you distribute, 99% of the time you have to collect like terms. So let's distribute and collect like terms. 2 times 3x is positive 6x. 2 times positive 2 is positive 4. Now bring everything else down so you can get ready to collect like terms. Now to be like terms, they have to have the same variable and exponent. So in this case, there's 3 terms with an x on it. X plus 6x is 7x plus 2x is 9x. We combine those like terms. Now, there's a constant here, positive 4. Is there another constant on the left side? No, so we just bring down the positive 4. Now, 2 steps left. Subtract the 4 and divide by your coefficient of 9. So we subtract 4 from both sides. We get 9x equals 396. And now you divide both sides by the coefficient, which is 9. Now we get a value. X equals 396 divided by 9 gives you what? 44. Any questions so far? If you have a question, please ask. Now write down all this work because on this second example that you're going to do on your own, the denominator is 3. You have to make sure you multiply everything by 3 except what's in your parentheses. And remember, there's a negative 1 touching the parentheses or a positive 1 touching the parentheses always if you don't see anything there. So multiply everything by 3 except 2x plus 3 in the parentheses. And then do the same steps we did on the red example. Go ahead and try number 2. Now let me walk you through what just happened on this question while you copy the work here. The 3 was distributed to every term except the parentheses. So as you can see, 2x plus 3 just came down untouched. Then once that happened, it got rid of the fraction. That's the point of doing this, to get rid of fractions so you don't have to work with fractions all the way through. Now, you distribute, get these values, and then collect like terms. If you combine 2x minus 6x plus 3x, it equals negative 1x. Bring down your minus 9 equals 240. And the last two steps are always similar. Get rid of this term and divide by your coefficient. So we add 9 to both sides and then divide by negative 1 coefficient. So your answer is x equals negative 249. All right, let's move on to the next page. On this page, it's again solving equations, but instead of asking you for the answer at the end, they're asking you for missing equations in your process. So, what I like to do is solve this myself. If I solve this myself off to the side, I can look at these steps and know how they got from one place to another. Now, to save some time, I'm going to do it right here on this screen and show you. But I do recommend that you solve it yourself off to the side and compare your steps. So let's start over here, number 1. On the first step up top, the first thing you have to do is distribute. Once you distribute, you get this as a result. 15x plus 15 minus 7x equals 3x plus 40. So we distributed and brought everything else down. Now, because we distributed on the following line, it tells you distributive property. So that kind of shows you the order. What they're asking here is what step got you to this point. You with me? So let's just keep going as if we were solving it on our own, and we'll talk about the properties in the along the way. So here we have 15x plus 15 minus 7x equals 3x plus 40. What I would do next is the step that always comes after distributive property, which is combine like terms. As you can see here, they already combined the like terms. What did they combine? They combined 15x minus 7x. That's why they put 8x over here. Now, if you're at this point, 8x plus 15, 8x plus 15 equals 3x plus 40. What would be the next step? The next step is getting the variables to the same side. So you move the smaller one, minus 3x on both sides. Now, what comes in this empty line is the results from doing this. So 8x minus 3x is 5x. Everything else just comes down. So we have 5x plus 15 equals 40. Now, what did we do to both sides here? We subtracted 3x. What do we call a property that's subtracted? Subtraction property. Now, I also put additive inverse because additive inverse is also subtraction property. Because the additive inverse of positive 3x is negative 3x. Now, on the next line, we get 5x equals 25. What do you think they did to get 5x equals 25? They subtracted 15 from both sides. Since they subtracted from both sides, they call this property, again, subtraction property. And now the last one, division property, is what's going to get them to this point, the final answer. So we can see easily what needs to be divided there. Both sides need to be divided by 5, and we get x equals 5. So the two missing steps were this equation and this equation. So here's a hint. The properties tell you what you should be doing there. So if they give you the properties and ask for the missing equations, use the properties to help you. And then if they ask you for the properties, but they give you the equation, then use your steps to help you pick the property. Copy it all down. Now, I want you to try the next example on your own. I wrote it in instead of having a white and black sheet there, so go ahead and continue on number 2 on your own. Yes? Yes, they can give you the second one and not the first one. But if they do give you the second one, then you start off by combining like terms, right? Now, my recommendation, always search for a parentheses because on a large percentage of the problems, there is going to be a percentage of a parentheses on the first step, especially on multi-step equations. On easier ones, no. But anything that's multi-step is going to have a parentheses in it. And that's usually one of the first two steps you do, distribute. So go ahead and try number 2. Good question. Go ahead and try number 2 on your own. All right, let's review this question. So we're going to start from the top over here. First step, distribute on both sides. So once you distribute on both sides, that means the property that follows says distributive property because how we got to these values are using distributive property. So when you distribute, you get 2x plus 4, bring down your minus 5 and your equal sign. 3 times x is 3x, 3 times 1 is positive 3. Now, again, like terms, every time you distribute, you look to see if there are like terms to collect. So in this case, they did collect like terms. 4 minus 5 gave them negative 1. So what did they do? They combined like terms. That's why the step shows that. Now, we're at the same spot we were over here where we were trying to get the variables to the same side. So over here, two things you can do. You can move the 3x to this side or move the 2x to the other side. Now, because I teach it in this way, I'm going to do it this way. Move the smaller one. So subtract 2x from both sides, and that leaves you with negative 1 equals x plus 3. Now, some of you wrote this as x plus 3 equals negative 1. Is that the same thing? Let's check. Positive x, positive 3. Positive x, positive 3 equals a negative 1. Equals a negative 1. So as long as you move it around without changing the values, then your equation's the same. So I don't care if you wrote it like this or the way I wrote it. They're both correct. Now, last step, you're trying to get the x by itself, so the only step left is to subtract 3 from both sides. What do we do to both sides? We subtract it. That's why the property is subtraction property. And now the values we get are x equals negative 4. Now, you don't have to read it as negative 4 equals x. Whenever you read an equation or an inequality, you read from the variable forward. So x equals negative 4 is the right way to read this. Any questions so far? All right. If you can see up here, there's 8 pages on this review. We're on the 4th page, so we're about to get halfway through. Now, I don't mind if we don't get to the worksheet today, as long as we get to the full review today. All right, now we get to the perimeter questions. So there's two different ways they're going to throw perimeter questions at you on any standardized test, whether it's the EOC now or the state exams, SATs when you're trying to get into college. They're still going to ask you the same types of questions. They want to know that you know how to find the perimeter and find an area using expressions. So, two ways of doing this, right? One way is to memorize the perimeter formula. Perimeter is twice the length plus twice the width. Now that is one way. Now you can plug in what you have here for the length and what you have here for the width, wherever you see length and width. And then you can work with the perimeter formula. I found that this ends up confusing more students rather than helping them. So let me show you the method that I use to solve these types of questions. And you'll notice that when I do number 2, I use the same method. Even though there's no figure here, I draw a figure on number 2 because this is the way I think it's easiest to visualize. So let's go back here to number 1 to show you my method for creating this perimeter expression or perimeter equation. So now, the length is 5x squared plus 9x, which means the length down below is the same thing, 5x squared plus 9x, because this is a rectangular figure. So we know that two sides are going to be equal to each other, and the other two sides are going to be equal to each other. So now that tells me that the width is 3x squared on the left has to match the width on the right side, 3x squared. Now, perimeter is the outside of a figure. So all you have to do is add all the sides. I think adding all the sides right here in this figure is easier than working with the perimeter formula. So let's do the length first. Adding 5x squared plus 9x plus 5x squared plus 9x gives you 10x squared plus 18x. You only add the like terms together, so it has to have the same variable and the same exponent to be put together. Now we have to add the width. 3x squared plus 3x squared is positive 6x squared. Now this is not my simplified expression because there's still like terms to collect. What are the two like terms? 10x squared and positive 6x squared. So once I combine that, I get my final expression, 16x squared plus 18x. Now because I'm asking for an equation called b of t, then just put b of t equals in the front. That's just a label, calling it b of t. So let me do the second example, and then I'll let you do the third on your own. On the second example, even though there's no figure, I draw a figure, so I can use the same steps as I did on number 1. So here it says the length, well, write a perimeter equation P of t. The length is represented by the expression 4x squared plus 3x. So we label the top 4x squared plus 3x and the bottom 4x squared plus 3x. Now we keep reading, and it says that the width is 8x squared. So we label both widths as 8x squared. Now let's add the lengths together. 4x squared and 4x squared is 8x squared. And 3x plus 3x is positive 6x. Now let's add up the widths. 8x squared plus 8x squared is positive 16x squared. Now we combine the two like terms. 8x squared and 16x squared gives you 24x squared. And your positive 6x just comes down. Now, because they say call it P of t, you just put P of t equals in the front. Copy down the work and try number 3 on your own. I'll give you Now let's move on to the next page. On the next page, you should recognize these questions. I gave you two versions of these questions when we learned this lesson at the beginning of the year. So these are questions that they look complicated. They're long questions, but they're very easy to do. The words in here tell you very easily what you need to do with both expressions. Sometimes it's giving you a word that means add them together. Sometimes it's giving you a word that means subtract them. Sometimes it'll tell you to multiply them. So the words mean a lot. So in this case, after we read that whole word problem, the main thing we're looking at here is total items in both sections. If you're going to find the total of something, are you going to subtract it? No. Are you going to multiply it? Of course not. If I want to know how many mangoes and apples I have in my pocket, I'm going to grab both stacks out and do what to both stacks? Add them. So that tells you all I have to do in this question is add whatever you have for A of t with whatever you have for B of t. How are you going to add it? The same way you did these examples, by adding like terms. So over here, you have a t square in the front of both equations. You have a t value following it on both equations. And then you have a constant following that on both equations. So that tells you which ones are going to get added to which. Once you read total for both, think addition, and now we add the like terms together. These are obviously decimals, so use the calculator if you can. So all we do is add 10.26 with 5.06, and that would give me the first term, 15.32 t squared. Now they ask us to call the new equation C of t. So we're going to put C of t in the front equals, and now we do the next term. The next term is going to be negative 4.23t minus 5.59t. So make sure you don't mess up the signs there. If you put minus, then you don't have to put this negative on the bottom because minus is negative. So be careful how you use the calculator. Just in case, this is the calculator you should use, TI30X. Now, how you do it on this calculator is first you put 4.23, then touch the negative button. Now you put minus 5.59. Now, we don't have to put negative on that because we said minus. We touch the minus button. So if we press equals, we get negative 9.82 t. Now, calculator does this for you, but what just happened was, if the signs are the same, add and keep the sign. Lastly, we're going to put together the constants. They're both positive here. So it's just 4.49 plus 7.50. That gives you positive 11.99. And that is your new equation with both combined. So I just did that whole question without reading the context of the question, because the context of the question doesn't matter. What matters is what they're asking you to do with both equations or both expressions. So this could have been about aliens, about fish, about dogs. It doesn't matter. As long as at the end you read total in both, you know what you're going to do. You're going to combine by adding like terms. All right, so now on the next question, it is the same concept. On the next question, I want you to use the same logic we did for number 13 up top for the next example. And this is easier. You okay? This is easier because there's less terms. Over here, all we have is Higgins 4.6 and Con 1.3x. So read it, answer it. It should only take you a minute. Anybody at home have an answer? Anybody in class have an answer? Just one? What did you get? Yeah, the new expression, the C of x. What does it give you? 5.9x. Correct. It is that easy. You're probably thinking, well, it can't be that simple, right? I'm missing something. It is that easy. Word problems, the longer the word problem is, the more information it gives you, the easier it becomes. You understand? If I got less words, I would know less. So here we have Higgins and Khan eat many cheeseburgers each week, and both can be represented by the expressions below. Create an expression, C of x, of their combined weekly appetite for cheeseburgers. Combined. When you combine something, do you subtract it? Do you divide it? Do you multiply it? Of course not. You add them. So we're going to add the two expressions together and call it C of x, 5.9x. Yes, it is that simple. This could be, like I said about anything. I put cheeseburgers. This could be two sandwich making companies. This could be two Easter egg companies. It could be anything. If they say combine, you add both expressions. All right, let's move on to the next page. Now, this is the second to last portion of the review, and it is very important. Also, the easiest part of it, because you're just supposed to analyze these things. Analyze this expression. What does this expression mean, right? So, for example, if I start off with $1,000 in my bank account and I add in 40 bucks a month, how would that be an expression? Let's see. $1,000. I'm going to add 40 bucks each month. You with me? Now, doesn't that look similar to this equation, this expression on the left? So this is a similar context, right? But I give you the word problem down here. Now, what do you think is the difference between the red one and the orange one? The plus and the minus. That tells you on the plus side, I was adding money to my bank account. But on the minus side, is something going to be added? No, something's going to be taken away. Now, if you read the word problem, there's a word that tells you something's going to be taken away. Draining. It's either filling something up or draining it. Filling would be a plus symbol. Draining would be a minus symbol. So this is important on just analyzing a word problem and what it's saying. Okay? So, first of all, these are linear formats. How do you know it's linear? Because the biggest exponent is a 1. So these are both linear formats. And on a linear format, y equals mx plus b, this constant is always your y-intercept. And your y-intercept always is your starting point, your original value. You with me? So now we can probably answer A, B, and C without doing any more learning. Let's read this. This expression represents the amount of water left in a tank after draining X minutes. Just reading that alone will give me the answers to A, B, and C. Let's try it out. What does 1500 represent? 1500 represents the original amount of water. Now, luckily for you, these are all multiple choice style questions. So you're going to read and select, bubble in the answer. You're not going to have to write it in your own words like I just did. It'll say initial value, original value, starting value, something like that. Now here, what does the 30 represent? Now, the key there is what I circled at the beginning. The 30 has what in front of it? A minus. That tells you that that is the amount that's getting drained per minute. So amount drained per minute. And I say per minute because the word problem says minute. On my next example, it says seconds. So I'm not going to say minutes, I'm going to say seconds. So let's go back here. Now, last one, which is the easiest one to analyze here. What does the x represent? The beauty of the x value is that in the word problem, it's usually telling you what the x value represents. It says here, x minutes. So what do you think x represents? The minutes. Minutes passed. Does that make sense? Any questions on this? Now, on the example that I want you to do, I flipped it around on you. I'm going to ask you for these values, and I write these as A, B, and C. So use the same common sense here on how you match these to match it the other way around on this example. 200 minus 5x. Answer A, B, and C. I'll give you 3 minutes so you can copy the whole thing. All right, let's review this example. So this expression, 200 minus 5x, by the way, you can put y equals in front of any expression to make it an equation because y is also always the result of an expression. So you can put y equals 200 minus 5x. You can put y equals negative 5x plus 200, which is the same exact thing. As long as the 5 kept its sign and the 200 kept its sign, the values are still the same. Now, this expression represents the amount of water left in a gutter system after X seconds. So here on A, it says what value represents the seconds passed. That's simple because it tells us in the word problem. X in quotations represents seconds passed. So this is X. Now on the orange example here, what value represents the amount draining per second? Now, what tells you the value? The minus sign. Draining tells you that it has to be the number that's touching the minus, the number that the minus is attached to. So in this case, it'd be 5. Now, this could be 5 ounces. This could be 5 liters. It depends on how big this gutter system is. And now the last example, letter C. What value represents how much water was originally in the gutter system? Any starting value is the number that has no variable attached to it, the constant. So in this case, 200 has to be the starting point. Done. We got both answers. Now, just in case you do get a question like this over here, if you have y equals negative 6x, what's my starting point? Original value, draining, minutes passed. Same thing we just did, right? But now something's missing. I want you to understand what happens when something like this is missing. So, original value, do you know what it is? I do. You might not at this point. Draining. What represents the draining amount? 6. Minutes passed. What's represented by minutes? X. Little hint, X is always time. Right? In these word problems, X is always time. Now, original value is the only one that we're not seeing here. Original value is the constant. If you don't see a number, that means your starting point is what? 0. If there's nothing there, that means there's a +0 there. That just means that you started off with nothing in your bank account. It's a brand new bank account if this was about a bank account. You understand? If it said 100 here or 10 here, you started with 10 bucks in your bank account. But like I said, if you see nothing there, that doesn't mean it starts nowhere. That means it starts at 0. Now over here, this is the last page. So I'm going to do the first one in blue, let you try the second one in pink, and we're done with the lesson today. So notice there's no equal sign anywhere. Why do I mention that? Because a lot of people throughout the years will start reading these problems and start doing like the opposite of what they see, like this. If you see minus 2x, you do plus 2x. That is called inverse operation. Inverse operation is only used on equations. The key prefix on equations is equal. There's no equal sign here, right? So that tells you you are not doing inverse operation. It's way easier than that. You are just simplifying. So you're going to distribute, collect like terms, and that's it. You with me? So that's what we're going to do here on the blue example and let you try the pink one on your own. On the blue example, you have a parenthesis that tells you first thing is distribute. So we're going to distribute 2x times 6 to get positive 12x, and 2x times negative 3x, which gives you negative 6x to the second power. Why is it a second power? Because when you multiply, the rule is add the exponents. And if you don't see an exponent, there's an imaginary 1 up there. So now we bring down the other two terms, 2x squared minus 3x. After you distribute, you're always collecting like terms. So here we have 2x squared minus 6x squared. Remember, to be a like term, it has to have the same variable and the same exponent. So when you combine those, we get negative 4x squared. And these two are like terms right here. Negative 3x plus 12x is positive 9x. Now, always order your answer from biggest exponent to smallest exponent, which is standard form. So this is the right way to order your answer. Now, same concept on the pink example. Try it on your own. Take a full 2 minutes. I'll review it, and we're officially done with this review, part 1. All right, let's review this example. So over here, 3x needs to be distributed to both terms in the parentheses first. So 3x times 5 is positive 15x. 3x times negative 2x is negative 6x to the second power. Don't forget to add the exponents. Now bring down the other two terms, negative 2x and 6x squared in the front. Now what happens? 6x squared is a like term with negative 6x squared. What's 6x squared minus 6x squared? 0. 0 you don't have to write. So my answer is just going to be what I get from the two like terms in the center. Negative 2x plus 15x is positive 13x. That is your answer. Make sense? Any questions so far? All right, so I'm going to save this video. I'm going to put it on Google Classroom for you guys to look at. You can watch it during your classwork tomorrow, or you can ask me during your classwork tomorrow. Go ahead and turn in these notes to Google Classroom. I'm going to put the assignment, turn in everything you copied today into Google Classroom under notes.